Welcome, I'm Lisa Wee. I'm AVEVA's Chief Sustainability Officer, and thrilled to have you here for our Digital Net Zero event. As Ed mentioned, we're going to be talking about how technology and AI are driving decarbonization and the opportunity that that offers for industries, for governments, as well as society at large. And maybe just a quick word about AVEVA and how we approach sustainability. Now, we really think about it from two aspects. First of all, our own operational footprint, and we've set very ambitious commitments here to lead by example on mitigating our own emissions. But we also really have a focus on our technology handprint, and that is how we can work with our customers through the software that we make that is used across the industrial sector to help them enable their sustainability transitions and to decarbonize more rapidly. And we actually think that that's where we can have a role in driving exponential change, because of course there's only one of us, but we have 20,000 customers, and some of them represented here on the stage to tell you more about that. But obviously we are making significant progress on the energy transition, when we think about that at AVEVA and the role that technology and AI can play, we really break that down into 3 steps, and again, you'll hear a little bit more about that from some of the panelists today. First of all, we think that it's very important that we work to decarbonize existing infrastructure, and that we work with players that have been in the energy space for a very long time. But we also think that we need to work to accelerate the transition, especially with technologies that are already commercially viable. So for us, that really means looking to accelerate using technology, the deployment of renewables, the deployment of biofuels, as well as at the same time working to bring down the costs of those technologies that are still maybe less commercially viable. So pushing out the frontiers of that whole energy system. And so that really is about focusing on green hydrogen and of course carbon capture and storage, other new technologies that are out there. And so hopefully you will see from our panel today that we have representatives from all of these different sectors. They will share more about the opportunity of technology and AI. But just to give you one example, because we also see as a technology company, our customers look to us to understand the opportunity of AI. And we think that it has a huge role to play in improving productivity. One statistic that I'll share is just that we know that AI can increase productivity by 25%. That's huge in terms of worker efficiency. It allows for collaboration in entirely new ways. It frees up teams to focus less on routine work and more on the challenging work of actually realizing this transition. In the renewable space, we've worked with customers as varied as AGL in Australia, helping them to leverage AI to bring in real-time data and increase the productivity of their wind farms by over 20%. That's just one example, but there are many more that you'll hear today. So with that, I'm going to kick off and hand over to our panelists. Really welcome Rachel. I talked a little bit about the energy transition. I know that there's a certain order of things that has to happen, including we need to green our grid. Would love to hear more about how you see technology playing a role there, and also your work with government, since I know you've had collaborations in this space for a long time.
Yes, thanks ever so much, Lisa. Thanks for having us here today. And I think, give a wee bit of context. So SSE is a UK, Scottish headquartered electric utility. You could maybe describe this as a wee bit traditional in the way that you said there. And you're also absolutely right. Of all the sectors of the economy, electricity has to get to zero first, because if we take every gram of carbon dioxide out of electricity, then what you've got is a low carbon energy source which helps to decarbonise everything else, almost everything else, not quite everything. But the obvious things are transportation and heat, which are the next, I suppose, arguably the next 2 big sectors to decarbonise. So there's no question we're first up, and because of that, I would describe us as being on our journey of transition for quite some time now. We actually set our first carbon reduction target back in 2009, and then they were renewed. So our first carbon reduction target was to reduce in half the carbon intensity of electricity generated by 2020. We achieved that by 2017, and of course we set ourselves a new bunch of targets. By that time, what we were focused on was the net zero challenge. So back in 2009, we thought we might need to just reduce it by 80%. Now we know we need to get all the carbon out and balance it off. So I like to say that we're not, as a company, Johnny-come-latelys to all of this. And that, of course, has meant that we've been working really closely with policymakers for a very long time. Now, the other little bit of context that I just want to put in there is about the numbers, because I sometimes think carbon numbers help to make this come alive, I suppose. And I've been doing this job, so I've got the same job as Lisa, but for SSE, Chief Sustainability Officer, and I've been doing it for nearly 12 years. And of course, one of the big jobs of a CSO is to disclose your carbon inventory. The first year that I did it, we disclosed 25 million tonnes of Scope 1 emissions. That makes us an almighty emitter of carbon dioxide 12 years ago. And this year, the equivalent number is 4.3 million tonnes. So we're getting there. You know, we're sort of 3/4 of the way there, but it's not zero. And we have to get to zero because, as I said, you guys all depend on us to take all the carbon out, and it has to be zero. So I guess that's the next challenge, is getting us to zero.
Thank you. Thank you so much. And, you know, I gave some examples earlier about AI, but really happy to have Rodolphe with us here, who has a lot of expertise in this area. The example that I gave with AGL was really about using machine learning algorithms to make sure that we understand the equipment and how actually in this case, if we're not wind farms and we're facing into the wind appropriately. So that's a very specific example. I know we also work with Sentinor, which is a large solar company, and help them do predictive maintenance. So another example of AI and making sure that they can understand their equipment before it actually fails and take the appropriate action. But how do you see AI playing a role in the broader energy transition in the industrial space? Would love to hear from you as your perspective as an analyst.
Super. Thank you very much, Lisa. Can you hear me? Okay, nods. Thank you. So I'm a technology analyst and obviously a massive techno-optimist. And AI is one of those things that has really caught the imagination. I think digital twins is another one. And I'm going to touch a little bit on both of them. I like to go back to basics, right? What is AI? And I think that the whole discussion has been slightly warped by the emergence of OpenAI and ChatGPT, and that for a lot of people that's their first experience of interacting with a lot of AI. But actually the story begins much earlier, right? Back when I was at university already we were talking about AI. We were coming up to 50 years of development of AI solutions, right? So as of today, the best way to think of AI is a huge toolkit, right? And you've got to apply this huge toolkit to a huge set of problems that you have. And when you do that well, you get absolutely extraordinary results. Now, it takes a lot of experimentation, takes a lot of thinking about what the right... you can't just take any algorithm and apply it to any business problem, right? You've got to think about what the business process that goes with it and how the whole thing's going to work. Maybe ChatGPT hallucinating is not a problem in certain contexts because you're writing your wedding speech and it's a handy help. But maybe if you're running the grid and you need to make critical decisions on balancing the grid or optimizing assets on a wind farm, you can't live with those hallucinations. So it's all about very much applying it in a sensible way. And what we've seen in recent times is a huge scale-up, right? And all the progress that has come over the last 5-10 years has been because we've got a lot of cheap compute, huge amounts of available data, and even industrial data, right? There's been a lot of work in getting industrial data out of the silos, out of the assets, and then suddenly our models can do things that are quite remarkable, right? And that's where all the progress with ChatGPT has come from. What's AI good at? Basically, helping you in any repeatable situation, right? If there's a repeatable situation, then you can teach it, right? You can train the model to do what it needs to do. So driving a car, translation, face recognition, image generation, all of these things, manufacturing lines, right? It's not very good at space reasoning. It's not very good at exploratory work, right? You may have seen a great interview by Elon Musk where he's comparing, on the one hand, the AI they're using at Tesla and the AI they're using at SpaceX. Completely different, right? SpaceX, turns out AI, not very good at space exploration, can't use it for that. But you can use it for more and more things, right? We're getting better and better at working out how to use it as well as we can. So coding, R&D, there's a few papers making their round around R&D. So then we apply all of this to the grid. And this very long introduction actually gets to the point that you could apply it to every single step of your energy system, right? And that's what makes it so powerful, but also there's big promises, and it's going to take a while to realize all these big promises, right? You could apply it on asset design. My first big AI moment was watching a heat exchanger that AI had helped design. And you're trying to design it you're trying to optimize for multiple parameters at the same time. So you end up with something that's 40% more energy efficient, 40% less materials used, and hence lower embedded carbon. And you look at the thing and you think no human engineer would have conceptualized that, right? And that's a genetic algorithm, 10 million iterations, and you end up with something that you wouldn't have possibly imagined. So asset design, asset maintenance, predicting battery life, balancing the grid, providing flexibility on the grid, making it self-healing. So the list of jobs that you could apply AI to is absolutely considerable in your energy system, all the way down to energy efficiency and demand management, whether it's predicting your own use and where you're going to take that. And I haven't touched on digital twins yet, but maybe I'm out of time. Maybe we can pick up on that in a bit.
Yeah, absolutely. And I just love what you said about being very clear about the problem that you're trying to solve. We have an expression in our company, which is no random acts of AI. Please. Again, we've been at this for a while. We have a center of excellence around AI, and we've been building AI into our products for about 17 years. So, but one of the latest things that we did actually was use gray box modeling to improve the process of carbon capture and storage in some of our engineering tools. But I don't pretend to be an expert on carbon capture and storage, which is why I've brought one along. Really pleased to hand over to Hanne to tell us more about your model, about how you're seeing the opportunity of carbon capture and storage transform the energy system.
Absolutely. And I will not pretend to be an expert in the full value chain of carbon capture and storage, but I'm representing at least the carbon capture part of it, which we see is an important and necessary role towards net zero for those processes that we can't electrify, that was mentioned here by you, that we can't swap the fuels, but it's part of the process itself. So I'm happy that we now are seeing progress in this area where we are actually deploying carbon capture, because it's in fact not a new technology. I'm going to arrest you on that, Lisa. It is a technology that we have developed for decades, but what has been lacking has been the scaling of it. And as we're speaking, we are delivering across a number of industries. We are building a carbon capture plant. Actually, it's the very first industrial scale carbon capture plant at a cement facility in the world. We're delivering that to Heidelberg Materials, and it's going to be operational in 2026. So that is an incredible important progress for industry that is requiring carbon capture to reach net zero. It's actually 68% of the world's emissions, so we definitely need to decarbonize this industry. Along with that, we're delivering to a waste-to-energy facility and also towards bioenergy plants in Ørsted's facilities in Denmark. So here is examples of how carbon capture is both doing the carbon reduction part of the equation and also the carbon removal part of it, both required for the net zero transition. So now it is all really about the scaling of it. So how do we do that? Because we know that it is a cost-intensive investment to start with carbon capture. What we need to do is to repeat it. So we have these first-of-a-kind projects across multiple industries. Now we need to get the numbers up, because that's how we also can get the costs down. So as different governments are now investing in carbon capture, we can learn from that. This is how we de-risk the projects. This is how we can standardize and we Also in the company that I represent, SLB Capturi, we believe in the modularization part of it, because this is how we can do a lot of the activities outside of the site, and we have less impact for the emitters as they're taking the solution into use. And since we were talking about data here, I should touch about that as well. So how could data support us? Well, of course, data is important throughout the value chain, both in the engineering. How can we be more efficient about what we do? And also, as we're having these multiple carbon capture plants in operation, how can we have the quick feedback loops so that we can improve? Energy efficiency is an important aspect of carbon capture, and this is where we need to learn quickly, and this is where we also believe that AI could help us on that. We can build those models more quickly. Now, I also would like to touch upon one important aspect where the value of data really will come in hand, and that is that even though that, of course, we in the industry that have been waiting for this moment to see the realization of carbon capture plants, we have to understand that although we find these industrial plants to be the most beautiful thing we have ever seen, this is not why our customers will deploy the carbon capture plant. That is really, in truth, and trust in the end product, which is a decarbonized, either it's the electricity that is provided to the customer, is the decarbonization of the cement that is being delivered out of that plant, or it is in the value of the carbon removal that we see is being sold now in the voluntary carbon markets. And this is where we see how we can partner up, and together with the value chain of carbon capture, transport and storage, we will have that digital value chain to come along with it.
Thank you. I love that focus on partnership. And again, I know technology has helped, but policy has also helped. So I think this is a fantastic opportunity to transition over to Matt. Would just love to hear from you. You've had a lot of examples of how companies are driving innovation, but really would love to see what solutions that you see popping up in the global north and the global south. And also just transitioning, of course, we're at COP. So looking to this particular COP, what are you hoping to see come out of it?
Yeah, thank you, Lisa. So it's fascinating to hear the examples we've been discussing so far already. I was keen to, as you say, put it in context of what we're trying to achieve at the COP as a whole, which is working with countries to deliver a transition to net zero that allows us to keep temperature increases to 1.5 degrees. And that involves a radical change to the global energy system. It involves working with countries right the way across the world on the changes that are needed to get there. But it's also a huge opportunity. It's a massive opportunity on energy access, on being able to use these new approaches to energy systems to be able to broaden energy access in an affordable and secure way. It's about energy security. It's a really a sense of opportunity, and it's about reducing costs. So I think the global part of this is really powerful alongside the innovations that we're hearing. From the UK's point of view, we are very committed to supporting the international collaboration on innovation around energy systems. We particularly are proud to be part of the Mission Innovation, which we see as the sort of preeminent international platform for public-private collaboration on innovation work. There are 7 main flagship schemes under Mission Innovation. The UK co-leads one of those, which is around green-powered future mission. And the purpose of that is to show that by 2030, power systems across different geographies and different climates can operate in up to 100% variable renewable energy systems. And this is incredibly important. Obviously, the UK has a 2030 fully decarbonised power objective, but we want to be able to work with countries across the world to see how that kind of system can work. And as Hanno was saying, data is a critical part of that, as well as digitalization. That's the third pillar that the UK leads within that mission. And that's really focused on the digitalization of the energy systems, involving interoperable data exchanges, effective system integration, these various different technologies and approaches. And we, through this approach, we can then share the experience that countries are having when they are developing their own energy systems. So in the UK, we're developing publicly available standards for digital assets, for interoperable demand supply side response systems, and it's by being able to share the way that we approach these and we put the standards in place to be able to support the development that we can then help other countries across the world in creating systems with a sufficient flexibility to build within renewables. And a final point, within the Clean Energy Ministerial, the mission innovation is establishing an AI task force to look at a number of the challenges that are being raised here and the opportunities. So we'd encourage as many countries to participate in this as possible. Thanks.
Well, fantastic. Well, now you've heard a little bit from each of our panelists, so I'm going to jump into some follow-up questions. So having just heard from Matt, does anybody want to jump in on what they see as some of the biggest challenges, or jump into a response to what anybody else has said?
Yes, so I want to sort of take what Matt's just said down a level to the practical reality of what this is. So in the UK, we've got this fantastic mission, which is actually to take most of the carbon out of electricity by 2030. So we've got 61 months to do that in. And remember when I explained that we had 4.3 million tonnes of carbon dioxide as a company? So the question is how do we get that down to almost zero by 2030? And Matt's absolutely right that we know that this is going to be a renewables-led system. We all agree with that, and great strides are being made on that. We also need to build out the electricity grids. So in my own country example, I think most of you will know that the plentiful resources of wind and rain exists in the north of the country, but the plentiful numbers of people live in the southern parts of the country. So there is no plausible route for the UK to get to the net zero without taking an enormous amount of renewable energy from the north to the south. So we need to build out big grids, and there are technical challenges with that, and we're innovating around high voltage direct current. But the other piece of this jigsaw is about flexibility. So we all know, obviously, when the sun doesn't shine and when the wind doesn't blow, we've got a bit of a challenge. And one of the technologies that is sort of it's sort of like its time has come. It's not a new technology, it's been around a long time, which is hydroelectricity. And in the north of Scotland, we aren't endowed with the abundance of hydroelectricity as there is in Norway, but it's still not bad. And this is where technology comes in and is so clever and smart. So if you think about it, it's almost like a really complicated puzzle. With hydroelectricity, you've got a dam and you've got a reservoir. And as a company, we think that we're in the business of flood prevention, and we're also in the business of mitigating against drought. Now, and then you add into that all the environmental requirements. I'm a sustainability person, so I concern myself with this. So, for example, if you allow a reservoir to go down so far, you can expose little islands that and routes that, for example, I have a live example of a fox can go and deal. And if your reservoirs come down so far, then the fox can get across to what was an island where the ducks, a special type of duck, was nesting. So I'm trying to paint you a picture of complexity. Flood prevention, drought prevention, protecting ducks, and also, most importantly, in a way, is to provide that flexible generation when the sun doesn't shine and the wind doesn't blow. And what we've got is a product, it's called HydroGrid, that effectively puts all those parameters, all those different things, this is repeatable, we know this is going to happen again, that puts all those parameters in and then tells us, also combined with market data and wind data and precipitation data, and tells us what is the optimum way to run that hydro system for society, for the ducks, and also for I suppose, preventing a greater use of unabated gas generation, which is the alternative in these situations. So I wanted to just kind of bring that alive and how all that works and how it's all interlinked.
I love that. I love making it real. Go ahead.
If I can take Rachel's point and kind of go international with it, we did quite a lot of work recently around the flexibility of the grid and kind of the 5 dimensions of what makes the grid really flexible. And obviously you need dispatchable low carbon power, you need storage, right? You need your transmission distribution infrastructure, as you're describing so well in the UK case. as well as control of the demand and flexibility of the demand, which is in itself a huge challenge. And the last one is interconnectivity. And when we looked at grids all the way from Japan to California, it's very clear that nobody's got this right yet, right? We've got very few properly flexible grids. This is a huge, huge work in progress. And typically, most people do 1 or 2 dimensions well, right? In Europe, interconnectivity has been working pretty well for quite a long time. But it's very tough. And the other thing I would say, on the road towards totally net zero grids, it's absolutely not a linear problem, right? When you go from 0 to 10% renewable energy, not that big a deal. When you go to 50 to 60%, it's much, much harder, right? You start having unstable two-way flows of energy. You need to spend loads of capex on your traditional infrastructure, which is not up to it anymore. So it really is not a linear problem. It gets exponentially harder.
If I may introduce a kindred in this discussion as well, because I love that systemic view that you put forward. What I think is interesting, if we go a bit outside of our now UK, Norway perspective, waste to energy is really an interesting area if we think about that step change from having the landfills, lots of methane emissions, now taking it into incineration and have the energy and heat out of it. So that is a really important way to support the grid system, offload the electricity demand to heat homes and in industries, and really rather use these waste heat streams and use it for something usual in this context. And it's not that many years since we banned the use of landfills in Norway. And when we see more on a global view, the opportunities there are immense, and it would be really good to see that plotted into this total overview, so to have to offload the grids. Huh?
Just to quickly add as well, one of the interesting discussions I've been hearing is the sort of reflection on the fact that bringing in renewables into systems where you have developed energy infrastructure, like in the UK and other countries, has had a huge benefit that you've been able to use the infrastructure, certainly up until potentially the sort of 50-60% margins. And that has allowed a very sort of rapid transformation of the sector without putting, up until those points, strain on creating new infrastructure. We're now at the point where, that infrastructure really needs to develop and be built. But we're also working with other countries where it's about access, where it's about creating new infrastructure from the beginning. So there we need to really be learning from, the experience that we're having in transforming systems about how to do this in the most effective and, most value for money way. Thanks.
And for those who maybe were not part of one of the plenary sessions yesterday with Al Gore, where he showed that there are more solar panels in the state of Florida than in the continent of Africa. That was a very sobering moment that, again, was brought to light, I think, with use of technology of the climate trade system. And clearly there's a lot more to do on the generation side as well as building out the grids. And that's going to require a lot of partnership. I know partnership is a theme that we all have in common. So maybe, Hannah, I'll hand over to you to talk more about the role of partnership in developing your value chain.
Absolutely, and I think we have a very good example of how we in 2021 came together through what we turned out to be a partnership, but with the same goals and ambition when it came to climate, and that was Ørsted, that is power company in Denmark that already have done an amazing transition from coal-powered stations and now being on the biomass side. We have Microsoft that at that time had newly put their pledge forward on becoming a net negative company and to remove all their emissions since they started up in a garage, I believe, in 1976. And then we had just established our company after really seeing that there was a pull for the carbon capture to be taken into use. And with this common thread of sustainability and ambition, we decided on, okay, we are going to accelerate a bioenergy with CCS project. We don't know how to do it yet, but we are determined that together and using our strengths, we are going to make it happen and work towards that. So I can't really explain the great happiness the day that this project was decided to be taken the final investment decision on back in 23, and that this is now being delivered. And Microsoft really has two roles in this setting. One thing is, of course, also their contribution on the financial side on purchasing the carbon removal credits, that together with the Danish government fund enable this project to move forward. And then, as I touched upon earlier, also how do we build trust in the product? How can we use data through the value chain to build that trust and verification of what is being delivered out of the process? So I believe, yes, partnerships, collaboration is the absolute must for scaling these kind of technologies. And as I said, also, we are dedicated to the carbon capture part of it. We are dependent on having this great collaboration throughout the value chain with a number of different transports and storage providers, because this needs to fit together with wherever the emitters are. And also, of course, the public-private collaboration and how we are seeing now how this is being matured and how to enable the private to take part together with the public funding is crucial for us to really accelerate moving forward. And I believe that is a lot of the discussions going on at this COP29 as well.
Public-private partnerships is a big reason we're all here at this COP. Rachel, anybody else want to jump in just on the role of partnerships?
I think there's a couple of sort of observations about, first of all, the renewable energy industry, and then the grids industry, because they are different. You think of our renewable sector as being hyper competitive, and if you've got something that's hyper competitive, collaborations are a bit more tricky. But of course, what we're seeing with the deployment of offshore wind are joint venture structures to an extent, that we've not really seen in the energy industry before. So to give you a practical example, SSE is in a joint venture with Equinor building the world's largest offshore wind farm at Dogger Bank. Now, sometimes I think we're taking offshore wind for granted a little bit, and we need to be, it's still reasonably early days. So while it's true, it's mature. SSE's got 3 operational offshore wind farms, but Dogger Bank has got a first-of-a-kind turbine, so a 14-megawatt turbine. It's absolutely massive. It's got a first-of-a-kind boat, because you can't put these things up without a really big boat. And we've also got first-of-a-kind high-voltage direct current technology. Now, this is a £9 billion offshore wind project. It is absolutely massive. It's not the sort of thing that SSE would do on its own. So there are commercial collaborations, very, very commercial, that are happening all over the sector. So that's the first sort of observation, is that that's happening. Now, those first of a kind, the point of this is that they're not that we won't be doing another first of a kind. The whole point of this is that it's replicable. And of course it's hard doing first of a kind things. And we need to get to the second and the third and the fourth really quite quickly. And I suppose, our big ask of the public sector is, please speed up your consenting. I understand why, it's not a blame thing, but that's what we collectively need to do. The second observation, though, is non-commercial collaborations. And if you think of this in grids are natural monopolies. Monopolies don't, by definition, there isn't a competitor. And it is in our global interest to be collaborating much more closely. There is no point in every electricity system on the planet having different specifications and standards for the way in which the systems are run. So the opportunity for more standardisation is in all our best interest, because the only thing we are competing on is access to the supply chain, because we're all trying desperately to build out our grids as quickly as possible. Supply chain's not big enough. So we can help them by having a bit more commonality in terms of our standards and our specifications. That is a big prize if we can pull that off.
It's great. So again, the role of standardization. And just to come back to what you were saying about the size of these turbines, I was sitting having a discussion with another member of the delegation who had mentioned that these wind farms and these turbines are getting large and large, and what does that do to the whole value chain? because if they keep on getting larger, then the vessels need to keep on getting larger, and it has all sorts of knockoff effects on the value chain that then actually slow progress down, because just when you've done your first of a kind, if all of a sudden next year the turbine is even larger, maybe some of the examples that the know-how that you've built gets even more delayed. So again, the role of standards there. Does anybody want to jump in on the question of standardization?
Well, important part, if going back to the carbon capture and storage part again, that would be the access to transport and storage is really a great barrier for accelerating the full industry. And while we're seeing a lot of progress there, the storage, as I say, no emitter will take their FID on a project before they know where to store the CO2. In some locations, it's a possibility to reuse some of the infrastructure that is there, or it's already available somehow. Others, we will need to have some intermittent ways of doing it before it's really made available. And in this space, the standardization actually of the CO2 and how that is to be delivered is also how it allows for enabling that market to have storage as a commodity for the emitters, where if one storage is not available for some reason, it could be shipped to another one or piped to another one. So that is an important aspect as we move forward. Just to tag on to sort of the first of a kind and how to move forward to the second and third, the scalability that you touch upon here is very interesting. I think in terms of CCS, really it is to have the first of a kind is truly the opener for the others to follow, in the term that it typically would set up a hub or a connection point for others to connect. So back to the example of Ørsted, they have 2 locations in Denmark where they're developing this. And what they really aim to do is to allow others to connect to it, becoming a CO2 transport hub. So not only to bring forward the carbon removal aspect, but to have fossil emitters in the vicinity to connect to their location, because this is a major stopper for many emitters to continue on their decarbonisation journey.
And just to maybe bring in a first of a kind that is certainly leveraging digital twins. So Rodolphe, prepare yourself to jump in maybe more here. But in the UK, we've been working with Protium Energy to build a plant that will be delivering 1 ton of green hydrogen per day. But again, it's a very expensive endeavor to be number one. And using digital twin technology, they're expecting to increase their ROI by over 300%. And again, that's going to be foundational to building this second plant and then growing further. So I would love to hear more from you, Rodolphe, just about the opportunities for digital twins as well that you see in these new first-of-a-kind opportunities.
Super, thank you. Digital twins, again, a source of confusion for some people. So just in one sentence, what are they? They're going to be a digital representation of your asset or your system in the virtual world, right? And then you can get to work on it, right? And it can be something as simple as a widget or as complicated as a whole grid. And what can you do with it? Well, you can start working, you build in the physical properties, right? How things move, the dynamics, how it responds to heat, okay? And you can build increasingly complex simulations and scenarios. And when it comes to the whole digitization story, this is the kind of stuff that allows you from, reporting and looking at metrics and looking backwards to simulating on the fly in real time. You could even write your code on how you can control this asset or this grid even before you've put any physical infrastructure down. And so I hadn't heard the 300% stat, but in some ways I'm not surprised because the more complex the system is, the more it pays to make all of these mistakes in the digital world, not to experiment and, by putting infrastructure down, right? I mean, in the manufacturing world, they used to build wooden models, right, of their manufacturing line just to see what would clash. Well, now you do all your clash detection in the virtual world, it's much easier, much faster. And then you can simulate it. And then you can bring in AI. You can have AI agents that are going to work on your digital twin. It's all virtual, but the AI is learning and doing simulations, maybe 10 million simulations on the digital twin to then optimize every single aspect of it that you care to, right? The sustainability of it, what materials you choose. It's very important, the sustainable product design, of course. So the possibilities are endless. It's
And I know we've certainly been building a Gen AI assistant into our tools. One of the reasons we've been doing it is because I was told we want our engineers doing more time engineering and not just reading manuals. So one of the things that the assistant can do is help it read through existing manuals and standards and give answers quite quickly to that. So that's just, again, another Gen AI example. But would love to hear from our panel about any other examples that you find that you're seeing in terms of use of AI in your own operations or across your industries.
I can give it's probably everybody's favourite, but it's another environmental one. So when we were given planning permission to build an offshore wind farm right off the northeast coast of Scotland, that area has large puffin colonies. So I don't know if everyone knows what puffin is, but they're beautiful little birds. They're quite characterful, it's fair to say, and they're quite special. So, of course, we were given an environmental condition on our planning consent, which was to monitor the colony of puffins. Now, if you're trying to monitor puffins, if you've seen a puffin, they're remarkably similar, and it's actually quite difficult not to count the same puffin twice. So we've got a generative, I think is what you call it, but machine learning. So what we've applied is a system that basically learns each puffin, and I think we could probably give every puffin in Scotland its own name, so we're able to count accurately the puffin numbers. And of course that's a machine that is learning that that the machine and the filming of them can spot the differences so it's a great little example, but I love it.
Yeah, very powerful. And again, tying back to the conversation we had about, of course, decarbonization, but also conservation of nature at the same time. And also, I think, since we've come back to AI, I know there's a big focus now on responsible AI in particular, and having an approach to that. It's an area a lot of governments are looking at. Matt, is there anything that you would want to share about where you see the responsible AI discussion going, or again, collaborating with companies in this area?
Yeah, I think there's obviously a sort of huge amount of potential in this space. We are very interested in working with countries on the way that AI can be used for a range of different areas. So that's something, as I discussed, in the SEM-MI space. There is a new task force that's being set up on AI, which a number of countries and other partners are going to work together in exploring the role that AI can play in energy systems and improving the efficiency and effectiveness of energy systems. We're also funding some projects out of the UK, which are part of AI for Decarbonisation Innovation Programme, which again is sort of looking at, well, how can this contribute to supporting countries in their net zero ambitions? So I think we're keen at looking at how this can contribute on the journey that countries are going through, but I think it's fair to say that it's still relatively sort of new in the application to decarbonisation process at the moment. So as that applies internationally, most of our focus is on the innovation side rather than the support of large-scale deployment.
And again, I think we certainly see AI as an accelerator. Sorry, Rudolf, did you want to jump in?
Oh, on responsible AI, just a couple of words. Actually, to me, it works on 3 different levels, right? One is you can make your tool more responsible, so it's less of a black box and you understand what's going on. Now, that can be extraordinarily difficult. You look at the first few layers of your model, right, and you see how it digests the input. You look at the last few layers, see how the output comes out. But actually, your whole model is 100,000 layers deep, right? So you've got no idea what's really going on. So that's hard. It's a big problem to solve. I think we'll make progress. Then there's responsible use of AI, very much in the sense of the EU regulations on that, which is for a whole bunch of applications, you're just not allowed to have a black box model. All right, makes sense. You can still have AI helpers, right? AI in the human loop, and that makes sense. And then finally, on the responsible use, I think you've got to talk about resource intensity as well, right? It's driving a huge amount of energy demand. All these new data centers, whether it's in the Guildford area, I think, where they've already kind of bought out all the electricity in that area out to 2030 or something like that. or similar areas in the US, right, where they just monopolize all of the clean energy that's produced there. I think my hope is we'll end up in a world where we have very large research and development models, like the ChatGPTs of this world, and actually a race to actually compactify some of the models, right? How do I give you 80% of the performance, but it runs on your laptop? There's signs that could be the way the industry goes, and some of the competitive nature of the industry is kind of pushing people that way. We'll see. Time will tell.
Yes, and certainly we're hearing a lot from our cloud providers about the move to SLM, so the smaller language models as well, more efficient AI chips, but also going back to getting more aligned on what are the principles of green software in the first place. So certainly at AVEVA we're part of the Green Software Foundation just to make sure that we are mindful of the footprint of our own AI and our broader digital solutions, and that we're also contributing learnings, but also measuring things the same way. If we measure it one way and our cloud providers measure it another way, it's not very helpful to people. So again, coming back to that standardization piece. But Hane, anything you want to jump in and say?
I was just thinking an area that is really important and valuable for AI application is in the area of permitting when it comes to renewable and for CCUS applications, because we know that that is a major hurdle both for the applicants to fill in and to provide all the information that is required, and not at least on the receiving end, which also is challenging to have the amount of people and the processes to actually go through them. And what we see is really keeping projects back is the permitting process. So it's a great space of opportunity here.
I know Rachel and I were both at the same dinner where we heard from Chris Stark about his example of permitting, and obviously just to share one example there that I know the last coal-fired power plant in the UK, just outside of Nottingham, took about 3 months to permit back in the 1960s, and I believe you and many others in this space have projects that are taking considerably longer.
Yes, absolutely. And actually, there is a little bit of development, and there are tools. I mean, you must be aware of some of the tools that are emerging. So first of all, you're absolutely right. It took 3 months to permit the last coal power station in the 1960s. We've just finished building an onshore wind farm in Shetland that from beginning to end took 18 years. So clearly we've got to sort this out. But I think everybody's in violent agreement that needs to be sorted. So at least in the UK, and I'm very hopeful we'll get there. But there's this tool called Optioneer. So there is a difference between the single site permitting, which can be challenging in its own right. But when you're talking about linear infrastructure and you're talking about overhead lines, and of course when we talk about expanding grid infrastructure, that's what we're talking about, or to an extent there is some going subsea. And of course, as we all know, that it can be challenging for communities to be hosting nationally significant infrastructure. So there is some developments of a tool called Optioneer, which is useful for the company that's developing the linear infrastructures, the big overhead line pylons. But actually, there's no reason why that technology couldn't be given to the communities and to empower communities to be able to understand themselves what are the limitations to those choices for the route for the overhead line, and we, along with some others, are testing this out on some communities to see how they interact with it, because of course the constraints when you're trying to plot an overhead line, there are good laws that mean that you can't put it through ancient woodland, rightly so. And actually, when you're trying to do it, you get quite constrained quite quickly into where you can take that route. And if there are machines that can help communities do that and give them a sense of empowerment, then fingers crossed that might help. It's not just about consenting, the literal permitting of it. This is about public consent in its widest sense and about bringing people along with you on that journey. But of course, the biggest challenge for the people who are creating these models is is actually how can you make sure that they're trustworthy, because that's the ultimate issue for the communities. How do they not, their cynicism or their fear around this, yet this has to be absolutely watertight. So that's the challenge. We've not cracked that challenge yet, but we're certainly giving it a go.
That's definitely a reason for optimism. So I know, first of all, we're coming to the end of our session and just wanted to thank you all. I also know that we're at the almost end of our first week of COP. We've got rest day. Some people have arrived, some people will be leaving. Just wanted to hear from each of you as a wrap up about what you'll be taking away, if you are, and really what you're most optimistic about so far from this COP process. So Matt, over to you.
Yeah, happy to start. I mean, there have been so many discussions at this COP that are getting quite advanced about the steps that are needed for the energy transition, that I've found that things have moved on really in the last couple of years. The understanding that you need to have a fully systemic view, you need to look at all the different factors that play towards a fully decarbonised power system, and the focus on the really critical barriers. So as Rachel was saying, permitting in the UK is absolutely kind of top there amongst the barriers that need to get addressed. But it's a conversation we're also having with a lot of other countries. So, many other countries are also finding permitting as pretty much their number one barrier of being able to build out the infrastructure. So there's a lot of sharing of experience and lessons from this, which I'm taking as a real positive as we look, in the UK to get towards 2030 decarbonised power system. Others are also trying, at different paces to get to the same outcome. And we're very much getting into the detail of how we share, breaking down the specific barriers of getting there. So I take that as a real positive.
For me, it is really about seeing now these new bold ambitions and being in the UK Pavilion. I must say that I was really happy to see that outcome of your next commitment. So I would say, yeah, it is ambition that we see the leaders coming through and take that position. I would say it is the interest, so the discussions that we have, the interest in the different technologies. And I would say that it's also to see the progress. So being in the carbon reduction and removal space, to have the 6.4 Paris article going through, that was an important one. And I think that although there's a lot of discourse around it still, we just need to be happy about the progress that we're doing. There's still work to be done, but let's not have the great be the enemy of good. So that's what I'm positive about. And let's now see that the 2025 brings real implementation and following up on those bold commitments. I'm a relative COP novice, but I've been very interested in the ability of some leaders to see through the cycle, right, through the current political cycle, and to reaffirm kind of long-term views. And as Matt was saying, taking the politics out of it and working on the systems change and the understanding of what it takes to get there has been extremely positive. So if I'm completely honest, I swing from hope to despair and back to hope again, if I'm totally honest. So, been to a number of COPs and been, like many of you, utterly devoted to this cause for a very long time. And I think what I'm going home with is, compared to my other experience at COPs, I think I sort of agree with Matt. I think there is a higher degree of sophistication in the debates that I'm being privileged to be part of, and a sense of realism. So yes, the ambitions and the targets are important, but actually this is the hard yards of delivery. Let's just do it. Let's get on with it. And that's probably what I feel most of all. And that's giving me hope, but also utter determination. I think is what I'm going home with.
Well, fantastic. I think, again, from just ending with the AVEVA note, I think you can see that we put this panel together because we wanted a diversity of voices, and I think that's what we do continue to get through the COP process. We get to hear from voices from all over the world, from civil society, from the corporate sector. I think that's, again, extremely important, and the message that we'll be carrying back to to our own employees and beyond. But I also think that what was been given me the most optimism is, yes, the ambition, and thank you for acknowledging that we are in the UK Pavilion, but also the fact that businesses remain really committed. We did get a lot of questions about, well, there'll be less businesses at this COP, and I think, yes, maybe, but the businesses are here to say that this is because we believe that this is an imperative and that the transition is happening, and we are continuing to do the business of transition and working on that implementation and working with policymakers to understand and share our views on why that's so important. So thank you all for coming to join us. Thank you for our audience, and we'll end it there.